Hello, and welcome to a journey into the most extraordinary illusion you'll ever encounter. Right now, as you watch this video, your brain is convincing you that you're seeing reality. But here's something that might unsettle you. The vivid, detailed world you're experiencing at this very moment, the colors, the shapes, the sense of depth and movement, none of it actually exists the way you think it does. Your brain is crafting an elaborate fiction, a controlled hallucination so convincing that you've never questioned it. And the strangest part? This isn't a glitch in the system. It's exactly how your brain is supposed to work. I'm glad you're here, wherever you are in the world, whether you're settling in for the evening or taking a quiet moment in your day. If you enjoy exploring the mysteries of consciousness and the hidden workings of the mind, you've found the right place. Consider giving this video a gentle like, and if you'd like to join others who find wonder in the intersection of science and philosophy, subscribe for more journeys like this one. Now, before we dive deeper, I should mention that everything we'll explore today is based on decades of neuroscience research and cognitive psychology. This isn't speculation. It's the remarkable reality of how your brain actually operates. And while it might challenge some fundamental assumptions about perception and reality, I think you'll find it as fascinating as I do. Take a moment and look around you. Notice the richness of detail, the clarity of colors, the seamless way objects seem to exist in three-dimensional space. Your brain wants you to believe that what you're seeing is a faithful reproduction of the external world, like a high-definition camera capturing reality exactly as it is. But neuroscientists have discovered something far more intriguing. Your brain isn't recording reality, it's constructing it, moment by moment, using a combination of sensory input and sophisticated guesswork. Consider this. Right now, photons of light are hitting your retina, creating electrical signals that travel along your optic nerve. But those raw signals are nothing like the rich visual experience you're having. They're more like scattered data points, incomplete and ambiguous. Your brain takes these fragments and weaves them into the coherent, meaningful world you perceive. It fills in gaps, makes predictions, and creates details that aren't actually there in the original data. This process happens so smoothly, so automatically, that you never notice it occurring. But it's happening constantly, with every glance, every moment of perception. Your brain is essentially running a real-time simulation of reality, and that simulation is so convincing that you experience it as the real thing. The implications of this are profound. If your brain is constructing reality rather than simply recording it, then what you experience as real is actually a creative interpretation influenced by your expectations, memories, and even your emotional state. Two people can look at the exact same scene and experience genuinely different realities, not because they're interpreting things differently, but because their brains are literally constructing different perceptual worlds. This isn't some abstract philosophical concept. It has real, measurable effects that you can experience right now. Your brain's reality construction system can be demonstrated, tested, and even tricked in fascinating ways. And understanding how this works doesn't just satisfy curiosity. It reveals something fundamental about the nature of consciousness itself. Let me share something that perfectly illustrates this principle. Have you ever noticed that when you're driving on a long highway, the road ahead seems to narrow to a point in the distance? Your brain knows that roads don't actually get narrower, so it interprets this visual information as depth and distance. But what if I told you that this interpretation can be fooled? There are optical illusions that can make two identical lines appear to be different lengths, simply by changing the context around them. Your brain's interpretation system, usually so reliable, can be led astray by clever visual tricks. This brings us to a fascinating question. If your brain can be tricked into seeing things that aren't there, or seeing things differently than they actually are, what does that tell us about the nature of reality itself? Are we all living in our own personally constructed versions of the world, each slightly different from everyone else's? The answer, according to modern neuroscience, is yes. And this isn't cause for alarm, it's cause for wonder. Your brain's reality construction system is one of the most sophisticated information processing systems in the known universe. It takes incomplete, ambiguous sensory data and transforms it into a rich, navigable world that allows you to survive and thrive. But here's where it gets really interesting. Your brain doesn't just construct visual reality. It constructs your entire sense of what's real and what isn't. The memories you have, the emotions you feel, even your sense of self, all of these are constructed by the same neural processes that create your visual experience. And just like visual perception, these constructions can sometimes diverge from objective reality in fascinating ways. Think about a vivid memory from your childhood. You can probably recall specific details, the way the sunlight looked, the sounds you heard, maybe even the way something smelled. That memory feels real, doesn't it? It feels like you're accessing a recording of something that actually happened. But neuroscientists have discovered that memories aren't recordings at all. They're reconstructions, built anew each time you remember them. And each reconstruction can be subtly different from the last, influenced by your current state of mind, recent experiences, and even suggestions from others. This means that your most cherished memories might not be accurate records of the past. They're creative reconstructions, influenced by everything that's happened to you since the original event. Your brain takes fragments of stored information and weaves them together with current knowledge and expectations to create what feels like a coherent memory. But that memory might be quite different from what actually occurred. And if memories can be reconstructed and altered, what about your sense of experiencing the present moment? Right now, as you process these words, your brain is taking in information from multiple senses, visual, auditory, perhaps tactile, and creating a unified experience of now. But neuroscientists have found that this now is actually a construction too, assembled from sensory inputs that arrive at slightly different times and are processed at different speeds. Your brain synchronizes all this information to create the illusion of a unified present moment. But it's doing more than just synchronizing, it's predicting. Based on your past experiences and current context, your brain is constantly making predictions about what you're likely to encounter next. These predictions actually influence what you perceive, sometimes so strongly that you might see or hear things that align with your expectations rather than with what's actually there. This predictive aspect of brain function helps explain why two people can witness the same event and come away with genuinely different accounts of what happened. Their brains, operating with different sets of expectations and experiences, literally construct different versions of reality from the same sensory input. But perhaps the most remarkable aspect of your brain's reality construction system is how it handles uncertainty and ambiguity. The world is full of unclear, partial, or contradictory information. Your senses are constantly bombarded with more data than you can consciously process. So your brain has evolved sophisticated filtering and interpretation mechanisms that extract the most relevant information and fill in the gaps with educated guesses. Most of the time, these guesses are remarkably accurate. Your brain has been trained by millions of years of evolution and a lifetime of experience to make predictions that usually align well with reality. But sometimes the guesses are wrong, and when they are, you get a glimpse into the normally invisible process of reality construction. Have you ever had the experience of thinking you saw something out of the corner of your eye, only to turn and find nothing there? Or hearing someone call your name when no one actually did? These aren't signs of malfunction. They're glimpses of your brain's prediction system at work. Your brain, trying to make sense of ambiguous sensory input, made its best guess about what was happening. And sometimes those guesses create experiences of things that weren't actually there. This same predictive system is responsible for much more dramatic phenomena too. People can have vivid, detailed hallucinations that feel completely real. They can develop false memories that seem as genuine as any true recollection. They can even experience their own body in distorted ways, feeling disconnected from their physical self, or perceiving their limbs as being in different positions than they actually are. These experiences might seem like exotic neurological curiosities, but they're actually extreme examples of processes that are happening in everyone's brain all the time. The difference is just a matter of degree. We're all experiencing controlled hallucinations, constructed realities that feel completely authentic, but are actually creative interpretations of ambiguous sensory data. And this brings us to something truly mind-bending. If your brain is constantly constructing reality, rather than passively receiving it, then the boundary between imagination and perception becomes surprisingly fuzzy. When you imagine something vividly, your brain activates many of the same neural networks that would be active if you were actually perceiving that thing. The main difference is in the strength and source of the signals. During normal perception, sensory input provides strong signals that help anchor your brain's constructions to external reality. During imagination, the signals are weaker and come primarily from memory and expectation, rather than from current sensory input. But the basic construction process is remarkably similar. This similarity helps explain why imagination can feel so real, and why, under certain conditions, imagined experiences can be mistaken for real ones. Your brain uses the same tools to build both perceived and imagined realities. The main thing keeping them separate is the strength and reliability of the sensory anchor points. But what happens when those anchor points become unreliable? What happens when the system that usually keeps your constructed reality aligned with external reality starts to malfunction? The results can be profound and sometimes disturbing. People can lose the ability to distinguish between their internal mental constructions and external reality. They might see things that aren't there, remember events that never happened, or feel convinced that their thoughts are being controlled by external forces. These experiences reveal just how much we normally depend on our brain's reality construction system working smoothly. When it works well, we feel grounded in a stable, predictable world. When it doesn't, the very foundations of reality can seem to shift and change unpredictably. But even in healthy brains, the reality construction system can be influenced in subtle but important ways. Your emotions, your expectations, your cultural background, even your current physical state can all influence how your brain constructs reality. This means that your experience of reality is deeply personal and subjective, shaped by everything that makes you uniquely you. As we continue this exploration, we'll dive deeper into the specific mechanisms that your brain uses to construct reality. we'll look at how optical illusions reveal the inner workings of visual perception, how false memories demonstrate the reconstructive nature of recall, and how your brain's prediction system can sometimes lead you to experience things that exist only in your mind. We'll also explore what happens when these systems go wrong and what those breakdowns can teach us about the normal functioning of consciousness. And we'll consider the philosophical implications of living in a world where reality is constructed rather than simply perceived. Because understanding how your brain creates reality isn't just an academic exercise. It's a key to understanding yourself, your relationships, and your place in the world. When you realize that everyone around you is also living in their own constructed reality, it can change how you think about disagreements, misunderstandings, and the nature of truth itself. So settle in and prepare to question some of your most basic assumptions about perception and reality. What we're about to explore might challenge your understanding of consciousness itself, but I think you'll find the journey as fascinating as the destination. In our next section, we'll start by examining one of the most powerful tools neuroscientists use to understand reality construction: optical illusions. These carefully crafted images can trick your brain into seeing things that aren't there or failing to see things that are. And by understanding how and why these illusions work, we can begin to unravel the mystery of how your brain creates the rich, detailed reality you experience every moment of your life. Right now, as you sit there watching this, your brain is performing one of the most sophisticated magic tricks in the universe. It's taking scattered fragments of light hitting your retina and transforming them into the vivid, three-dimensional world you see around you. But here's what might surprise you. Much of what you're seeing isn't actually there at all. Your brain is filling in enormous gaps, making educated guesses, and quite literally, painting reality into existence. And some of the most convincing parts of your visual world? They're complete fabrications. Let me show you what I mean. Have you ever noticed that you have a blind spot in each eye? Right now, there's a region in your visual field where you can see absolutely nothing, yet you're completely unaware of it. Your brain seamlessly fills in this gap with information it predicts should be there, creating a flawless illusion of complete vision. This isn't a minor detail. It's a fundamental feature of how you see the world, and it reveals something profound about the nature of perception itself. Welcome to the fascinating world of optical illusions, where the carefully constructed reality your brain creates begins to crack and reveal its inner workings. These aren't just amusing parlor tricks or internet curiosities. They're windows into one of the most important discoveries in neuroscience: that what you experience as reality is actually an elaborate construction project happening in real time, inside your head. Consider the Hermann grid illusion. When you look at a simple pattern of black squares separated by white lines, you'll see gray dots appearing and disappearing at the intersections of the white lines. But here's the remarkable thing. Those gray dots don't exist anywhere except in your mind. The image contains only pure black and pure white, yet your brain creates these phantom gray spots and makes you see them as clearly as anything else in your visual field. This happens because your visual system is designed to detect edges and contrasts, not to create a pixel-perfect reproduction of the world. The cells in your retina and visual cortex are constantly comparing the brightness of different regions, looking for boundaries and changes. When they encounter the specific pattern of the Hermann grid, this comparison process creates a systematic error. The intersections appear darker because your brain is interpreting the surrounding white space as brighter by contrast. But your brain doesn't just leave it at that. It takes this erroneous information and integrates it seamlessly into your visual experience. Those phantom gray dots feel just as real as any other part of the image. You can't simply decide not to see them any more than you can decide to see ultraviolet light. Your brain has committed to this interpretation, and it presents it to your consciousness as indisputable reality. This reveals something crucial about how vision works. Your eyes aren't cameras, passively recording whatever light happens to fall on them. They're active interpreters, constantly making decisions about what's important, what's likely to be there, and how to make sense of incomplete information. And sometimes, those interpretations create experiences that have no basis in external reality. The Müller-Lyer illusion demonstrates this even more dramatically. Two lines of identical length appear to be different sizes simply because of the direction of arrow-like shapes at their ends. Even when you measure the lines and confirm they're the same length, even when you know intellectually that you're being deceived, you cannot stop seeing them as different. Your brain's interpretation system is so powerful that it overrides conscious knowledge. Why does this happen? The arrows at the ends of the lines trigger your brain's depth perception system. Lines with inward-pointing arrows look like the inside corners of buildings, while lines with outward-pointing arrows look like outside corners. Your brain has learned that inside corners appear shorter due to perspective, while outside corners appear longer. So it automatically corrects for this perceived perspective effect, making the lines appear different lengths even though they're actually identical. This correction happens so quickly and automatically that you never experience the original, uncorrected image. By the time visual information reaches your consciousness, it has already been interpreted, adjusted, and modified based on your brain's expectations about how the world works. You're not seeing the raw sensory data. You're seeing your brain's educated guess about what that data represents. But perhaps the most unsettling illusions are those that create the vivid experience of movement from completely static images. The rotating snake's illusion, created by Japanese psychologist Akiyoshi Kitaoka, shows circular patterns that appear to spin continuously, even though nothing in the image is actually moving. The effect is so convincing that many people initially refuse to believe the image is static. This illusion exploits the way your brain processes motion. Your visual system doesn't detect movement directly. Instead, it infers motion by comparing the position of objects across time. The rotating snake's pattern contains carefully arranged colors and contrasts that trigger your motion detection system in a rhythmic, cyclic way. As your eyes make tiny, involuntary movements called microsaccades, different parts of the pattern stimulate your motion detectors at slightly different times, creating a false but compelling sense of rotation. What's particularly fascinating is that you can partially control this illusion. If you stare directly at one spot in the image and keep your eyes perfectly still, the motion slows down or stops. But the moment you shift your gaze or let your eyes move naturally, the rotation starts up again. This demonstrates that the illusion isn't just happening in the image, it's happening in the dynamic interaction between the image and your own eye movements. These motion illusions reveal something profound about the nature of visual experience. The sense of movement you perceive isn't a direct recording of objects moving through space. It's a conclusion your brain reaches based on patterns of changing stimulation over time. And like all conclusions, it can sometimes be wrong. Your brain can be convinced that movement is happening when it isn't, or that stillness exists when things are actually moving. This predictive aspect of vision extends far beyond illusions. Right now, as you look around, your brain is constantly making predictions about what you're likely to see next. When you turn your head, your visual system prepares for the expected changes in your visual field. When you reach for an object, your brain predicts how it will look from different angles as your hand approaches it. These predictions are usually accurate, which is why vision feels so effortless and reliable. But sometimes the predictions are wrong, and when they are, you get a glimpse into the normally invisible process of visual construction. You might see something that isn't there, or fail to notice something that is there, or experience familiar objects as somehow different or strange. The change blindness phenomenon illustrates this beautifully. When researchers show people images or videos where significant changes occur during brief interruptions, viewers often fail to notice even dramatic alterations. A person might change clothes, objects might disappear, entire buildings might be replaced, and observers remain completely unaware of the changes. This happens because your brain doesn't actually store detailed visual information about everything you see. Instead, it relies on being able to look around and gather information as needed. But when changes occur during the brief moments when your attention is diverted, your brain's prediction system fills in what it expects to see rather than what's actually there. You experience a continuous, stable visual world, but that experience is largely constructed from expectations and assumptions rather than from detailed visual memory. This has profound implications for how we think about eyewitness testimony, memory, and the reliability of perception in general. If you can fail to notice major changes happening right in front of you, what else might you be missing? How much of what you think you're seeing is actually just what you expect to see? The rubber hand illusion takes this question into even stranger territory. In this experiment, participants watch a fake rubber hand being stroked, while their real hand, hidden from view, is stroked in exactly the same way. After just a few minutes, most people begin to feel as if the rubber hand is their own hand. They flinch when the rubber hand is threatened, and they report feeling the touches on the fake hand rather than their real one. This illusion demonstrates that your sense of body ownership, your feeling of which parts of the world belong to you, is also constructed by your brain rather than being directly given by your senses. Your brain integrates visual information about what looks like your hand with tactile information about where you feel touches, and it constructs a sense of ownership based on the correlation between these inputs. When the correlation is strong enough, as in the rubber hand illusion, your brain can be convinced that a clearly fake object is actually part of your body. This reveals that even your most basic sense of self, your feeling of being located in a particular body, is subject to the same constructive processes that create all of your other perceptions. Virtual reality researchers have pushed this even further, creating full-body illusions where people feel as if they've swapped bodies with someone else, or even with non-human avatars. By carefully controlling the visual and tactile information people receive, researchers can make them feel as if they're inhabiting a different body entirely. Some people report profound changes in their self-perception and behavior when experiencing these illusions, suggesting that our sense of identity is more fluid and malleable than we usually imagine. But illusions don't just reveal how individual perception works. They also show us something important about the social construction of reality. Different cultures show different susceptibilities to various optical illusions, suggesting that the way we construct reality is influenced by our experiences and expectations, which are shaped by the cultural environment we grow up in. The Mueller-Lyer illusion, for example, is much stronger in people who have grown up in carpentered worlds, full of rectangular buildings, straight lines, and right angles. People from cultures with more curved organic architecture show less susceptibility to the illusion. Their brains haven't learned the same associations between arrow-like shapes and architectural perspectives, so they don't make the same automatic corrections. This suggests that the reality construction process isn't just biological, it's also cultural. The way you see the world is influenced not just by the universal features of human neurology, but also by the specific visual experiences you've had throughout your life. Your brain's prediction system has been trained by your particular environment, and that training influences how you interpret ambiguous sensory information. As we delve deeper into the mechanisms behind these illusions, we begin to see that they're not just curiosities or entertainment. They're revealing something fundamental about the nature of consciousness itself. Every moment of your waking life, your brain is performing the same basic process that creates optical illusions. It's taking incomplete, ambiguous sensory information and constructing from it a coherent, meaningful experience of reality. The difference between an illusion and normal perception isn't that one is constructed and the other isn't. They're both constructed. The difference is just that in illusions, we can see the construction process more clearly because it produces results that conflict with our expectations or with other sources of information. This realization opens up profound questions about the nature of truth, reality, and knowledge itself. If everything you perceive is constructed rather than directly received, then what does it mean to say that something is real? How can we distinguish between accurate and inaccurate perceptions? And if different people's brains construct reality differently, how is communication and shared understanding even possible? These questions become even more pressing when we consider that the same constructive processes that create optical illusions also create your memories, your emotions, and your sense of self. If visual perception can be unreliable, what does that say about the reliability of memory? If your brain can be tricked into feeling ownership of a rubber hand, how stable is your sense of personal identity? In our next section, we'll explore exactly these questions as we turn our attention to one of the most disturbing ways your brain creates false realities. Through the construction of memories that feel completely real, but never actually happened. We'll discover how your brain can convince you that you remember events in vivid detail, complete with sensory information and emotional content, even when those events are entirely fictional. This isn't just about the occasional fuzzy recollection or minor details getting mixed up over time. We're talking about detailed, emotionally charged memories of significant events that your brain has created out of nothing more than suggestions, expectations, and the natural reconstructive processes of memory itself. And perhaps most unsettling of all, these false memories can feel just as real and convincing as your most treasured genuine recollections. The implications of what we've just explored extend far beyond visual tricks and perceptual curiosities. Because if your brain can construct convincing visual realities that don't exist, what about your memories? What about those vivid recollections that feel so real, so detailed, that you'd stake your reputation on their accuracy? Here's where the story takes an even more unsettling turn. Right now, you probably have memories that feel absolutely genuine, memories so clear you can almost step back into them. Perhaps it's a childhood birthday party, a conversation with a friend, or even something that happened just last week. You can probably recall specific details, the way the light fell across someone's face, the exact words that were spoken, the emotions you felt in that moment. These memories feel like faithful recordings of the past, like you're accessing a library of perfectly preserved experiences. But here's what neuroscientists have discovered, and it's profoundly disturbing. Many of your most vivid, detailed, emotionally charged memories never actually happened. They're reconstructions, fabrications created by the same neural processes that generate optical illusions. And unlike visual illusions, which you can identify as false once you understand how they work, these false memories feel just as real and convincing as any genuine recollection you possess. This isn't a rare phenomenon affecting only people with neurological conditions. It's a fundamental feature of how memory works in every human brain. Studies suggest that entirely false memories can be implanted in a significant percentage of people through nothing more than suggestion and social pressure. Researchers have successfully convinced participants that they remember being lost in a shopping mall as a child, witnessing demonic possession, or even committing crimes that never occurred. The process begins with your brain's tendency to fill in gaps. Unlike a video camera that records everything continuously, your brain stores memories as fragments, scattered pieces of sensory information, emotions, and context. When you try to remember something, your brain doesn't simply retrieve a complete recording. Instead, it reconstructs the memory from these fragments, filling in missing details with information from other memories, general knowledge about how the world works, and expectations about what probably happened. This reconstruction process happens every single time you remember something. And each time you remember an event, you're not just recalling it, you're subtly changing it. The act of remembering actually modifies the memory, incorporating new information, current emotions, and updated understanding into the stored representation. This means that your most frequently recalled memories, the ones that feel most vivid and certain, may actually be the most distorted. Consider what happens when you try to remember a conversation from last month. Your brain retrieves fragments. Perhaps you remember the setting, the general topic, and how you felt afterward. But the specific words that were spoken, those are largely reconstructed based on what you think you might have said, what the other person typically says, and what would make sense given the context. Your brain seamlessly weaves these reconstructions together with genuine memory fragments, creating an experience that feels like authentic recall. The Elizabeth Loftus experiments demonstrated this process dramatically. Participants watched videos of car accidents and were later asked about what they saw. Those who were asked, how fast were the cars going when they smashed into each other, gave higher speed estimates than those asked about cars that contacted each other. More remarkably, participants who heard the word smashed were more likely to report seeing broken glass in the video a week later, even though no broken glass was actually shown. This shows that the language used to discuss a memory can actually alter the memory itself. The word smashed activated associations with more violent collisions, and these associations became integrated into the participants' recollections of what they had witnessed. They weren't lying or being deliberately inaccurate. Their brains had genuinely reconstructed the memory to include details that were never there. But false memories can be far more elaborate than simple details about car crashes. In what's known as the Lost in the Mall study, researchers convinced participants that they had been lost in a shopping mall as young children. They did this by presenting participants with 4 stories about their childhood, 3 true stories provided by family members, and 1 fabricated story about being lost. Initially, participants couldn't remember the false event, but when asked to try to remember more details over several sessions, about 25% of participants developed detailed memories of being lost, complete with emotional content and sensory details. These weren't vague impressions or uncertain recollections. Participants described specific details about what the mall looked like, how they felt, who found them, and what happened afterward. When the researchers revealed that the memory was false, many participants had difficulty believing it. The fabricated memory felt just as real as their genuine childhood recollections. This research has profound implications for eyewitness testimony, therapy, and our understanding of personal history. If memories can be so easily altered or entirely fabricated, how can we trust our recollections of important events? How do we distinguish between genuine memories and reconstructions that have been influenced by suggestion, expectation, or the natural distortions that occur over time? The answer is both simple and troubling. Often we can't. There's no reliable way to distinguish between a genuine memory and a convincing false one based solely on how the memory feels. False memories can be just as vivid, detailed, and emotionally resonant as real ones. They can include sensory information that seems impossibly precise, emotional content that feels authentic, and contextual details that appear to confirm their accuracy. This problem becomes even more complex when we consider the social nature of memory. Many of your memories aren't just personal recollections. They're collaborative constructions created through conversations with others. When you discuss past events with family members or friends, you're not just sharing memories, you're potentially modifying them. Details mentioned by others can become incorporated into your own recollection, even if those details weren't part of your original experience. The phenomenon known as the Mandela effect illustrates this on a collective scale. Large groups of people share identical false memories about public events, movie quotes, or product names. Many people vividly remember Nelson Mandela dying in prison in the 1980s, even though he actually died in 2013 after serving as president of South Africa. Others are convinced that the Monopoly Man wears a monocle, that Darth Vader says, "Luke, I am your father," or that there was a movie called Shazam, starring comedian Sinbad. These aren't just cases of people misremembering details. They're instances where large numbers of people have constructed similar false memories, often with remarkable consistency in the details. This suggests that the memory construction process follows predictable patterns, creating similar errors when people are exposed to similar conditions and influences. The mechanisms behind false memory creation reveal something fundamental about how your brain prioritizes coherence over accuracy. When faced with incomplete or contradictory information, your brain doesn't simply leave gaps or acknowledge uncertainty. Instead, it creates plausible explanations and fills in missing details to maintain a coherent narrative. This tendency toward coherence is usually helpful. It allows you to function effectively, even when information is incomplete. But it also makes you vulnerable to constructing false realities that feel completely authentic. Confabulation represents an extreme example of this process. People with certain types of brain damage may create elaborate, detailed stories about their experiences, even when those experiences never occurred. They're not lying or being deliberately deceptive. Their brains are simply working overtime to create coherent explanations for fragments of information that don't quite fit together. The result is vivid, convincing narratives that have no basis in reality, but feel completely true to the person experiencing them. But confabulation isn't limited to people with brain damage. Everyone engages in minor forms of confabulation regularly. When you try to explain your own behavior, motivations, or decision-making processes, you're often constructing plausible stories rather than accessing accurate records of your mental processes. You might be convinced that you chose a restaurant because of its excellent reviews, when in reality the decision was influenced by factors you're not consciously aware of, like the color of the sign or its proximity to where you parked. This storytelling aspect of memory construction has implications for how you understand your own identity and life history. The narrative you tell about your past, the story of who you are and how you became that person, is partially constructed rather than simply remembered. You select certain events as significant, interpret their meaning, and weave them together into a coherent, personal mythology. This story feels true because it's based on genuine memories and real experiences. But it's also a creative construction that emphasizes some aspects of your history while downplaying others. The malleability of memory becomes even more concerning when we consider how it can be influenced by authority figures, social pressure, or therapeutic techniques. People can be led to develop false memories of childhood abuse, alien abductions, or past life experiences through suggestive questioning, hypnosis, or other memory recovery techniques. These false memories can be extraordinarily detailed and emotionally devastating, affecting not just the person who develops them, but their relationships and families as well. This doesn't mean that all recovered memories are false, or that childhood trauma doesn't occur. But it does mean that the mere vividness and emotional intensity of a memory isn't sufficient evidence for its accuracy. The brain's memory construction system can create convincing false experiences under the right conditions, regardless of how genuine they feel to the person experiencing them. Understanding the reconstructive nature of memory also sheds light on why different people can have genuinely different recollections of the same event. It's not just that they're interpreting things differently. Their brains may be literally constructing different versions of what happened based on their individual perspectives, expectations, and subsequent experiences. This can lead to conflicts and misunderstandings that seem impossible to resolve because each person's memory feels completely accurate to them. The implications extend into the legal system, where eyewitness testimony has long been considered one of the most compelling forms of evidence. But research on memory construction shows that eyewitness accounts can be highly unreliable, especially when witnesses are questioned repeatedly, exposed to suggestive information, or asked to recall events after significant time has passed. A witness who seems completely confident and provides vivid details may still be entirely wrong about crucial aspects of what they observed. This research has led to important changes in how police conduct interviews and how courts evaluate testimony. But it also raises deeper questions about the nature of truth and reality. If our memories of the past can be unreliable and our perceptions of the present are constructed rather than directly received, what does it mean to say that something really happened? How do we distinguish between authentic experiences and convincing constructions? These questions become even more complex when we consider that the same neural processes responsible for false memories also contribute to creativity, imagination, and problem solving. The brain's tendency to fill in gaps and create coherent narratives isn't a flaw. It's a feature that allows you to function in a complex, often ambiguous world. But this same feature can sometimes lead you astray, creating experiences that feel real but have no basis in external reality. Perhaps most unsettling of all is the realization that you may never know which of your memories are accurate and which are reconstructions. That vivid recollection of your first day of school, that clear memory of a conversation with a deceased relative, that detailed recall of how you felt during a significant life event, Any of these could be partially or entirely fabricated by your brain's memory construction system. This isn't cause for despair, but it is cause for humility. It suggests that our confidence in our own memories and perceptions should be tempered by an understanding of how fallible these systems can be. It also highlights the importance of external verification, multiple perspectives, and careful documentation when accuracy truly matters. But there's another side to this story that's equally fascinating. If your brain can create false memories that feel completely real, what does that tell us about the nature of experience itself? Are false memories somehow less meaningful than real ones if they have genuine emotional impact and influence your behavior? And if the boundary between memory and imagination is more fluid than we usually assume, what implications does this have for creativity, storytelling, and the human capacity to envision alternative realities? These questions point toward an even deeper mystery about consciousness and identity. If your sense of self is built from memories that may be partially constructed, and if your perception of reality is created rather than simply received, then what exactly are you? Are you the stories you tell about yourself, even if some of those stories aren't entirely accurate? Are you the observer of constructed realities? Or are you somehow part of the construction process itself? As we continue this journey into the mechanisms of reality construction, we'll explore how your brain doesn't just create false memories and visual illusions, but can generate entire sensory experiences that have no external basis whatsoever. We'll delve into the phenomenon of hallucinations, where the boundary between internal construction and external reality breaks down completely, creating vivid, detailed experiences that exist only in the mind but feel absolutely real to the person experiencing them. These aren't just extreme cases of mental illness, though they certainly include those. Hallucinations can occur in healthy individuals under specific conditions, and they reveal something profound about the normally hidden processes that create all of your perceptual experiences. By understanding how and why hallucinations occur, we can gain deeper insight into the fundamental question that underlies everything we've explored so far. What is the relationship between the reality that exists outside your head and the reality that you actually experience? And this brings us to perhaps the most extraordinary demonstration of your brain's reality construction powers, the phenomenon of hallucinations. These aren't just the dramatic visions we associate with mental illness or psychedelic experiences, though they certainly include those. Hallucinations represent the ultimate expression of what your brain is doing all the time, creating rich, detailed sensory experiences from internal processes rather than external stimuli. Right now, as you listen to these words, your brain is maintaining a delicate balance. Sensory information from the outside world provides anchor points that keep your internal reality construction tethered to external reality. But what happens when those anchor points weaken or disappear entirely? What happens when your brain's prediction system begins operating without sufficient external correction? The answer reveals something profound about the nature of all perceptual experience. Hallucinations aren't a malfunction of the brain. They're the normal reality construction process, operating without its usual constraints. They show us that the vivid, detailed world you experience every moment isn't fundamentally different from the vivid, detailed experiences that exist only in someone's mind during a hallucination. Consider what happens during sensory deprivation. When people are placed in environments with minimal sensory input, floating tanks, soundproof rooms, or complete darkness, many begin experiencing hallucinations within hours. They might see patterns of light, hear voices or music, or feel sensations on their skin, all without any corresponding external stimuli. This happens because your brain's reality construction system doesn't simply shut down when sensory input decreases. Instead, it continues generating experiences, but without external anchors to keep those experiences aligned with reality. These sensory deprivation hallucinations reveal something crucial about normal perception. Even under ordinary circumstances, your brain is constantly generating internal activity that contributes to your perceptual experience. The difference is that this internal activity is usually calibrated and constrained by sensory input. When that input is removed, the internal generation process becomes more obvious, creating experiences that are clearly not based on external reality. But hallucinations can occur even with normal sensory input. And when they do, they can be indistinguishable from genuine perception. People experiencing auditory hallucinations don't just imagine that they're hearing voices. They actually hear them, complete with specific tones, accents, and emotional content. The voices seem to come from particular locations in space. They can be louder or softer than other sounds, and they can even be partially masked by real environmental noise, just like genuine sounds would be. Visual hallucinations can be equally convincing. People might see detailed figures, complex scenes, or intricate patterns that appear to exist in the same visual space as real objects. These hallucinated images can have proper lighting, shadows, and perspective. They can move realistically and interact with the genuine visual environment in ways that seem completely natural. What makes this possible is that hallucinations utilize the same neural pathways and mechanisms that create normal perception. When you hallucinate a voice, the auditory processing regions of your brain become active in patterns very similar to those that would occur if you were actually hearing a voice. When you hallucinate a visual scene, your visual cortex generates activity patterns that closely resemble those produced by genuine visual input. This similarity explains why hallucinations can feel so convincing. From the perspective of your conscious experience, there's no fundamental difference between neural activity caused by external stimuli and neural activity generated internally. Both types of activity are processed by the same brain regions and integrated into your ongoing stream of consciousness in the same way. The hypnagogic and hypnopompic hallucinations that many people experience while falling asleep or waking up provide a gentle introduction to this phenomenon. You might hear your name being called, see shapes or figures in your bedroom, or feel sensations of movement or touch. These experiences occur because your brain's reality construction system is transitioning between the states optimized for waking perception and those optimized for dreaming. During this transition, the usual balance between internal generation and external calibration can become unstable. Your brain might interpret random neural activity as meaningful sensory input, or it might continue generating dreamlike experiences even as your sensory systems are coming back online. The result is experiences that feel completely real, but have no basis in your external environment. Dreams themselves represent a fascinating form of hallucination that everyone experiences regularly. During REM sleep, your brain generates rich, complex experiences that can be visually stunning, emotionally intense, and narratively coherent. You might find yourself in impossible locations, interacting with people who couldn't possibly be there, experiencing events that defy the laws of physics. And throughout most of the dream, these experiences feel completely real and normal. What's remarkable is that your dreaming brain can create experiences that are far more vivid and detailed than anything you could deliberately imagine while awake. You might dream of reading text, examining intricate visual patterns, or having complex conversations, all generated entirely by your sleeping brain, without any external input whatsoever. The mechanisms that create dreams reveal something important about the relationship between perception and imagination. During REM sleep, the brain regions responsible for sensory processing become highly active, even though sensory input is largely blocked. Your visual cortex generates complex patterns of activity that create detailed visual experiences. Your auditory cortex produces the sounds you hear in dreams. Your motor cortex creates the sensation of movement and action. But perhaps most intriguingly, the prefrontal cortex, the brain region responsible for critical thinking and reality testing, becomes less active during dreams. This explains why dream experiences can seem completely reasonable, even when they involve impossible or absurd elements. Your brain's reality construction system is operating at full capacity, but its error checking and consistency monitoring functions are diminished. When you wake up, the return of prefrontal activity allows you to recognize that the dream experiences weren't real. But during the dream itself, they felt just as authentic as any waking experience. This suggests that the feeling of reality isn't an inherent property of genuine perceptions. It's something that your brain adds to experiences based on how they're processed and integrated. The Charles Bonnet syndrome provides another fascinating window into hallucination mechanisms. People with this condition, often those with visual impairments, experience complex visual hallucinations despite being aware that what they're seeing isn't real. They might see detailed scenes of people, animals, or landscapes overlaid on their actual visual field. These hallucinations can persist for hours and can be remarkably stable and detailed. What's particularly interesting about Charles Bonnet hallucinations is that they occur in people whose visual systems are damaged, but whose visual cortex remains intact. The brain regions responsible for processing visual information continue to generate activity, but without normal input from the eyes to constrain and guide that activity. The result is internally generated visual experiences that feel perceptually real, even though the person knows intellectually that they're not. This condition demonstrates the active, generative nature of perception. Your visual cortex isn't just passively receiving and processing input from your eyes. It's constantly generating patterns of activity that contribute to your visual experience. Normally, this internal generation is guided and constrained by external input, but when that input is disrupted, the internal generation can become the dominant source of visual experience. Musical hallucinations represent yet another fascinating category. People might hear complex musical pieces, complete with multiple instruments, harmonies, and rhythms, playing clearly in their auditory experience despite no external sound source. These auditory hallucinations can be so realistic that people initially assume they're hearing music from a neighbor's radio or a distant source. What makes musical hallucinations particularly intriguing is their complexity and coherence. The hallucinated music often follows conventional musical structures, with proper timing, key relationships, and stylistic consistency. This suggests that the brain regions responsible for musical processing and memory are generating these experiences using the same sophisticated mechanisms that normally process real music. The phenomenon of phantom limbs provides another perspective on how the brain can create convincing sensory experiences without corresponding external stimuli. people who have lost limbs often continue to feel sensations in the missing body part, sometimes for years after amputation. They might feel their phantom hand moving, experience pain or itching in fingers that no longer exist, or sense the position and posture of a limb that isn't there. These phantom sensations occur because the brain's map of the body doesn't immediately update when a limb is removed. The neural networks that formerly processed sensations from the missing limb remain active and continue generating experiences of touch, position, and movement. From the person's subjective perspective, these phantom sensations feel just as real as sensations from their remaining limbs. Phantom limbs illustrate a crucial principle about hallucinations and reality construction more generally. The brain's internal models and expectations can override or supplement external sensory information. Your experience of your body, like your experience of the external world, is partially constructed based on internal predictions and assumptions. When those internal models become disconnected from external reality, they can continue generating convincing experiences independently. The role of expectation in hallucination is particularly important. People are more likely to hallucinate things they expect to encounter or fear encountering. Someone who believes they might see ghosts is more likely to experience visual hallucinations of human figures. Someone who expects to hear voices might be more prone to auditory hallucinations. This isn't because the hallucinations are somehow less real or meaningful, but because the brain's reality construction system is influenced by beliefs, expectations, and emotional states. This expectation effect reveals something fundamental about all perception, not just hallucination. Your expectations and beliefs influence what you see, hear, and experience, even under normal circumstances. The difference with hallucinations is that these influences become strong enough to create experiences that aren't anchored in external reality. Drug-induced hallucinations provide yet another window into these mechanisms. Psychedelic substances like LSD, psilocybin, and DMT can produce extraordinarily vivid and complex hallucinatory experiences. Users might see intricate geometric patterns, experience synesthesia where sounds have colors or shapes, or encounter seemingly autonomous beings and environments. These substance-induced hallucinations occur because psychedelic drugs alter the normal functioning of neural networks involved in perception and reality construction. They can increase activity in visual processing regions, disrupt the normal filtering mechanisms that distinguish between internal and external signals, and alter the balance between different neurotransmitter systems that normally keep perception anchored to reality. What's particularly fascinating is that psychedelic hallucinations often have a quality of meaning and significance that feels profound to the person experiencing them. This isn't just because the experiences are visually striking or unusual, but because the altered brain chemistry affects not just perception, but also the systems responsible for assigning meaning and emotional significance to experiences. This highlights an important aspect of reality construction that we haven't fully explored yet: the emotional and meaning-making components. Your brain doesn't just construct perceptual experiences, it also constructs the sense that those experiences are meaningful, significant, or important. This meaning-making process can be altered by brain chemistry, emotional state, or expectations, leading to experiences that feel profoundly meaningful even when they have no basis in external reality. The phenomenon of shared hallucinations adds another layer of complexity to our understanding. There are documented cases of multiple people experiencing similar hallucinations simultaneously, particularly in highly charged emotional or spiritual contexts. These shared experiences suggest that hallucinations aren't purely individual phenomena, but can be influenced by social and cultural factors that shape how reality construction processes operate. This brings us to a profound realization about the nature of reality and experience. If hallucinations can feel just as real as genuine perceptions, if they utilize the same neural mechanisms and can be influenced by the same factors that shape normal perception, then what exactly distinguishes a hallucination from reality? The answer isn't as clear-cut as you might expect. From a subjective, experiential standpoint, there may be no difference at all. A hallucinated voice can sound just as clear and distinct as a real voice. A visual hallucination can appear just as detailed and properly lit as a genuine visual scene. The difference lies not in the quality of the experience itself, but in its relationship to external reality. But this raises deeper questions about the nature of reality and consciousness. If your brain is constantly constructing your reality from a mixture of sensory input and internal processing, and if this construction can sometimes operate independently of external anchors, then what does it mean to say that something is real versus imagined? Perhaps the most honest answer is that reality, as you experience it, is always a construction. Sometimes that construction is closely anchored to external stimuli. Sometimes it's influenced by expectations and beliefs. And sometimes it operates with minimal external input altogether. Hallucinations represent one end of this spectrum, but they're part of the same continuum that includes all of your perceptual experiences. This understanding has profound implications for how we think about consciousness, mental health, and the nature of human experience. It suggests that the boundary between normal and abnormal perception isn't as clear as we might assume. It also highlights the remarkable creativity and generative power of the human brain, which can create rich, meaningful experiences even when external input is minimal or absent. As we near the end of our exploration into how your brain creates realities that aren't there, it's worth reflecting on what these discoveries mean for how you understand yourself and your place in the world. You are not a passive observer of an objective reality. You are an active participant in the construction of your own experience. Every moment of consciousness involves your brain making countless decisions about what to pay attention to, how to interpret ambiguous information, and what meaning to assign to the patterns it detects. This isn't a flaw or limitation. It's one of the most remarkable capabilities of the human mind. Your brain's ability to construct coherent, navigable realities from incomplete and ambiguous information allows you to function in a complex world full of uncertainty and change. It enables creativity, imagination, and the ability to envision possibilities that don't yet exist. But it also means that your reality is more personal and subjective than you might have realized. The world as you experience it is shaped by your individual history, your expectations, your emotional state, and the particular ways your brain has learned to process information. This doesn't make your experiences less valid or meaningful, but it does suggest a certain humility about the nature of truth and perception. Understanding how your brain creates reality also opens up possibilities for intentionally shaping that reality in positive ways. If your expectations and beliefs influence what you perceive and experience, then cultivating positive expectations and beliefs can potentially improve your quality of life. If your brain's reality construction is influenced by attention and focus, then practices like mindfulness and meditation might help you construct more satisfying and meaningful experiences. Perhaps most importantly, recognizing that everyone's reality is constructed can increase empathy and understanding in your relationships with others. When you realize that other people's perceptions and memories are just as constructed as your own, it becomes easier to understand why they might see things differently than you do. Their reality construction system has been shaped by different experiences and expectations, leading them to construct genuinely different versions of the world. This doesn't mean that all realities are equally valid or that objective truth doesn't exist. External reality continues to exist independently of our perceptions of it, and some constructions of reality are more accurate and useful than others, but it does mean that accessing objective truth requires careful effort, multiple perspectives, and a willingness to question our own perceptions and assumptions. The journey we've taken together through optical illusions, false memories, and hallucinations reveals something profound about the nature of consciousness itself. You are not simply a consciousness observing reality. You are a consciousness participating in the creation of reality. Your brain is not just processing the world, it's actively constructing the world you experience moment by moment. This realization can be both humbling and empowering. Humbling because it reveals how much of what you take for granted about perception and reality is actually constructed and potentially fallible. Empowering because it highlights your active role in shaping your own experience and suggests possibilities for growth, change, and expanded awareness. As we conclude this exploration, I want to leave you with a thought that ties together everything we've discovered. The fact that your brain can create convincing realities that don't exist isn't evidence that reality is meaningless or that truth is impossible to find. Instead, it's evidence of the extraordinary creativity and adaptability of consciousness itself. Your brain's reality construction system represents millions of years of evolution, fine-tuning the most sophisticated information processing system we know of in the universe. It can take fragmentary, ambiguous signals and transform them into rich, meaningful experiences. It can learn, adapt, and create. It can imagine possibilities, construct narratives, and generate emotions. Most remarkably of all, it can become aware of its own processes, as you're doing right now by contemplating these ideas. The constructed nature of reality doesn't diminish the wonder and beauty of consciousness. It amplifies it. Every moment of your waking life represents an ongoing miracle of creativity, interpretation, and meaning-making. You are not just observing the universe, you are participating in bringing it into experiential existence. If you found this journey into the nature of reality construction as fascinating as I have, you might be interested in exploring how these same principles apply to an even more personal domain: your sense of self and identity. Just as your brain constructs your reality from sensory fragments, it also constructs your sense of who you are from memories, experiences, and beliefs. And just like perceptual reality, the self you experience might be more fluid and malleable than you realize. Until next time, remember that every moment of consciousness is both a mystery and a miracle, a construction so sophisticated that you rarely notice it happening, yet so fundamental that it shapes everything about your experience of being human. Thank you for joining me on this exploration into the extraordinary illusion we call reality. To the extraordinary illusion we call reality.